Welcome! On this channel, we share the freshest insights from the world of neural networks, hardware, and technology. Subscribe right now so you don't miss a thing. And if you need your own AI agent, reach out and I'll help you build one tailored to your needs. Okay, let us dive right into today's magical explainer. We are looking at a truly sizzling new model. Meet MiniCPM Vision 4.6 from OpenBMB. It is a 1.3 billion parameter multimodal hero, and it's beautifully designed to run directly on your edge devices. We're talking iOS, Android, and even flying drones. Imagine a world where your tiny device holds the vast intelligence of a massive data center, completely untethered from the cloud. That is exactly the beautiful future we are exploring today. Think of this little model like Samarglo from our digital fairy tales. Samarglo is a swift, winged messenger, a perfect symbol for an edge device that flies freely anywhere. It packs immense, intelligent power into a tiny, incredibly agile form. So what does this mean for you? Well, it means you can carry incredible artificial intelligence right in your pocket, with absolutely no internet required. Because it runs natively on edge devices, you get absolute privacy, blazing speed, and total independence. Your data never, ever leaves your hands. It is just a wondrous time for technology, right? The actual magic of neural networks is finally placed directly into our own hands. Now, the secret magic inside this incredible model is visual token compression. To picture this, imagine trying to fit an entire giant library into a tiny little backpack. It uses a mix of 4 times and 16 times compression rates to instantly shrink massive amounts of image data. This clever trick grants an incredible 1.5 times faster token throughput multiplier. Basically, it reads and understands pictures incredibly fast. It is like a glowing cyber loom spinning threads of light where thick golden beams of visual data are instantly compressed into tight, sparkling knots of pure energy. This lets our small model process vast landscapes of visual information without ever getting overwhelmed. Despite its tiny size, this brilliant blue gem of a model is a fierce underdog. It absolutely crushes much larger rivals. I mean, it consistently beats massive 8 billion parameter models, especially in optical character recognition, which is pulling text from images. It handles complex document reading like a massive 3 billion class champion. It is a powerhouse for dense paperwork. But, every hero has a slight weakness. When it comes to heavy mathematical logic and deep STEM reasoning, the larger giant models do still pull ahead. But for your everyday visual tasks, our Swift Messenger is practically unmatched in its weight class. To truly understand this magic, we really need to test our winged messenger in the real world. So today, we awaken Svarog's Forge locally on Ubuntu Linux. We are using an RTX 6000 GPU, and we have prepared a massive 48 gigabytes of VRAM. We launch Baba Yaga's terminal right through a Jupyter notebook, creating our magical forge where the trials will begin. It is actually fascinating to contrast the small, mobile nature of this model with the roaring, massive computational forge we are using to stress test it. We really want to push it to its absolute limits, just to see how far this tiny titan can go. Here are the 3 specific trials we have designed to test its strength. First, we will look at old, faded handwritten letters. Second, we will feed it complex financial tabular documents filled with dense numbers. And third, we will challenge it with an AI-generated wildlife video. Now at rest, the model slumbers very quietly. It barely takes up 1 gigabyte of memory. You could run this easily on a standard CPU without even breaking a sweat. It just waits patiently in the darkness until we call upon its immense power, ready to spring into action for these difficult tasks. We tested first on an old, tricky handwritten letter. And suddenly, the Kikimora strikes, tangling our local resources. Because processing dense visual context requires massive temporary memory, the VRAM consumption violently jumps over 26 gigabytes. It is as if thousands of glowing blue crystals violently burst forth, filling the entire room with chaotic, overwhelming computational energy. This happens because the model has to suddenly expand its context window. It needs to absorb all the intricate details of the messy handwriting. It proves that even a tiny model requires a massive amount of cognitive space to truly see a complex image. Now, this heavy cost of magic means we have to offload the visual processing directly onto the GPU. It actually takes almost 40 seconds just to process this single handwritten image. But, this high latency is a known family trait for these highly compressed, powerful little models. They are like deep thinkers. They process heavily and slowly when confronted with high-resolution images. But please do not worry. The wait is absolutely worth it. The model is carefully unspooling those tightly compressed knots of visual energy, making entirely sure it understands every single pixel before it finally speaks. And like Vasilisa the Wise, the model translated every single hidden word flawlessly. It clearly differentiated between faint commas and full stops on the aged paper, capturing the true essence of the ancient text. Next up, we handed it a very complex financial tabular document. We asked for specific appropriations, but explicitly excluding special accounts. This is a highly complex task, one that easily confuses even the large models. Yet it reasons through the entire maze of rows and columns, extracting the exact mathematical value with perfect accuracy. It navigated the labyrinth of financial data like a true master. Finally, we push its limits with a deep video understanding trial. We feed it an AI-generated wildlife safari clip, processing it frame by frame. The model carefully watches lions chasing zebras across the screen, and it captures the whole atmosphere with stunning detail. It wonderfully notices the dusty ground kicked up by the hooves and even the subtle panning of the camera. It provides an incredibly complete atmospheric answer for such a tiny brain. It really proves that it does not just see static shapes. It truly understands motion, context, and the unfolding story within the video. MiniCPM proves that immense power can live anywhere, right in your very hands. We are truly entering an era of sovereign edge computing. This liberates our true creativity from heavy cloud dependence, expensive internet connections, and monthly subscriptions. By mastering these small artifacts, we build a beautiful, independent world where intelligence is localized and entirely private. Please subscribe to our updates and consider becoming channel sponsors so we can explore this magic together. Huge thanks for your support. It really helps the project grow. Many more discoveries await us ahead in the new digital Cyber-Rus. So what magical tools will you forge when limitless AI is finally resting securely in your pocket?